Okay, guys, good evening, all of you. Am I audible? Good evening, all of you. Am I audible? Voice is clear. Can you please write in the chat window? Everything is fine. Thank you. Thank you for your confirmation. Perfect, perfect, perfect. So, a very good evening to all of you. A very good evening to all of you. And this is day two. We have already completed day one. This is day two. So, today we will see basically, we will see what garbage collector and heap and stack diagram. All of you, very important session today. As I told you, among all these sessions, today's session is most important session. So a quick recap, what we learned yesterday. Look, and then we will go to what? We will go to current session. So what we learned yesterday, and then we will go to what? Our current topic. So yesterday we have completed day one. So in the day one, basically, what I have discussed with you guys. So in day one, basically, I have discussed first variables. Okay. Then I told you that based on the data type, we have only two types of variable in Java. One is primitive variable. These primitive variables will hold values. And second one is reference variable. This reference variable will hold the address. Related to this address, today you will get more clarity. Today you will get more clarity regarding this address, how it is holding the address. Then based on the declaration position, where exactly you are going to declare the variable. Now variables are classified into what? Inside a class as well as inside the method. So again, inside the class, you have what? You have a static field as well as you have a non-static field. Inside a class, you have a static field as well as non-static field. And inside the method, you have a local variable and parameter variable. So clearly, I told you that class level, we have two types of variable at class, where we can declare at class level, where we are declaring at class inside the class. And here I told you what, that two variables are method level, where we can declare it method, and only class level variables are having default value. Then we discussed about this cello copy, very, very important. You understood how object is passing from one place to another place. And when we modify the value, then original object will be modified or original object will not be modified. So up to here, we have completed, guys. Up to here, we have completed. Now let's move to day two. So now we are going to move to day two, all of you. So let me save this. This is what day two. Day one we have completed. Now we are moving to day two. Today I will share the notes also. Day two. So guys, what I want to discuss today first, all of you. What I want to discuss today first. So today first I want to give you idea. As I told you, first today I want to give you the idea of what is garbage collection in Java or what is garbage collector in Java. Please try to concentrate. Very important. What is garbage collector in Java? What do you mean by garbage collector? Look. So what is garbage collector in Java? What is garbage collector in Java? Sir, as I told you, we have total what? We have four types of variables. Yesterday, I have given you the complete idea. Total four types of variables are there. Two class level variable and two is what? Method level variable. Two class level variable and two method level variables. So what I told you, where exactly they are getting the memory, where exactly they are getting the memory. Now, exactly where we are going to look at now where exactly we are going to store that memory. So what I told you, if I again give you the idea. So first one is what? First one is what? A static field. Just I'm giving you the recap. Static field. A static field where method area. Number two, non-static field. Non-static field. For non-static field, the memory is what? Where exactly the memory is available. The memory is available what? The memory is available in the heap area. The memory is available in the heap area. Okay. What about local and parameter variable? Local and parameter both. Local and parameter. So both variable, the memory is allocated. The memory is allocated in what? Stack area. Without wasting your time, if I give you a little bit idea, then it will become more easy for you to understand. Look, if I go here, just give me a time. So I have created one PPT based on those variables where it is. Just give me a second. Just give me a second. Should be there class loader and what this one. So maybe it is missing. Okay, no problem. Maybe it is not available in this particular laptop. It is available in my Google Classroom or something. I will check and I will what? I will give it to you tomorrow. Don't worry about that. That is not required. Please make a screen full. My screen is full only. Yeah, screen is full only. No problem. Now let's see. So what I explained, guys, what I explained, look at, I explained that what static field, these are available in method area, non-static field available in heap area, and local and parameter variable, it is available in stack area, all of you. Then what I want to talk today. So first I want to talk what is garbage collector in Java. What do you mean by garbage collector in Java? What do you mean by garbage collector in Java? Please try to concentrate. So guys, whenever we are creating any object, look, whenever we are creating any object in Java, that object is stored. Whenever we are creating any object in Java, whenever we are creating any object in Java, creating any object in Java, whenever we are creating an object in Java, object is going to store, object is going to store in a special memory, in a special memory called heap memory, called heap memory. Okay. So let's say here I have one heap memory. This is my heap memory, guys. In this heap memory, exactly what we are going to store. We are going to store what? We are going to store object. Okay, now exactly what we are storing in this heap memory, guys. Yes, I will provide. Please wait. I will provide the link for yesterday video also. Please don't write anything right now. At last, I will give you 10 to 15 minutes time to give you to solve your all the queries. Please concentrate right now in this particular in this particular video, in this particular webinar, because it's very, very important. Okay, please try to understand. Then at last, around 7:47, 45, I will ask to you. I will share the notes also. Just try to concentrate here very, very carefully because today's session is very, very important. In this heap memory, what we have objects. These are objects. Consider these are objects. So where these objects are storing, these objects are stored in this heap memory. Guys, these objects are storing in this heap memory. Please try to concentrate. Different objects are there. They are storing in this heap memory. Okay. Then we are creating multiple objects. We are creating multiple objects. We are creating multiple objects. Then what will happen? What will happen if we create multiple objects? Then memory is limited. Even though from from Java 8 and 9 version, Java has made so many changes in what their memory. Earlier it was permanent generation memory. Now it is a meta space. It is a meta space, but any memory is limited. Any memory is always limited. So what will happen now? Slowly with your objects, this heap memory is going to full. This heap memory is going to full. Then what will happen once my heap memory is totally full? Once my heap memory is totally full, look, then new objects are unable to store in this heap memory. New objects are unable to store in this heap memory. In that situation, what will happen? If you try to create more and more objects inside this heap memory, you will get one problem or you will get one runtime error. What is that? Out of memory error. Out of memory error. Out of memory error. Out of memory error. Everyone understood what I'm trying to say? Please write in the chat window. You got the idea what I explained? What is heap memory, where objects are created? Please write in the chat window. Come on, all of you, I'm requesting to all of you, please write in the chat window. So memory is limited. Memory is limited. And now in this memory, you are creating the object. Then what will happen? At a particular time, you will get what? Out of memory error. At a particular time, you will get what? Out of memory error. There is a chance of getting out of memory error. So look, another language like C++, if you talk about C++ language, in C++ language, programmer is responsible to allocate the memory as well as deallocate the memory. In another language like C++, if you talk about C++ language, so it is the responsibility of programmer to allocate the memory and to deallocate the memory. That means memory allocation, whose responsibility? Programmer. Memory deallocation, whose responsibility? Programmer. Okay, now memory allocation, whose responsibility? Programmer is responsible for memory allocation. Programmer is responsible for memory allocation. And programmer is also responsible for memory deallocation. Programmer is also responsible for memory deallocation. Memory deallocation. That means it is the programmer headache. It is the headache of the programmer. What? To allocate the memory as well as to deallocate the memory. To allocate the memory as well as deallocate the memory, it is a programmer headache. Okay. Then what about Java? Sir, in Java, we have automatic memory management. I will give you the complete notes in text file. Don't worry about that. So I'm just writing the bullet points here. I will give you the notes today only. Yesterday and today, both notes I will give you. Even I will give you the link also. So look, please try to understand what I'm trying to say. So in Java, we have automatic memory management. Automatic memory management. Okay. Programmer is only responsible for allocating the memory. Programmer is only responsible for responsible for allocating the memory. Allocating the memory. Programmer is only responsible for allocating the memory. Memory deallocation. Memory deallocation is automatically done by memory deallocation is automatically done by garbage collector. Okay, na? Memory deallocation is automatically done by garbage collector, guys. So who is responsible for memory deallocation? Memory deallocation is automatically done by garbage collector. Garbage collector is responsible for deallocating your memory. Garbage collector is responsible for deallocating your memory. Please try to understand. So memory deallocation is automatically done by garbage collector. Sir, what do you mean by deallocation, sir? I'm not understanding. Look, so garbage collector is a daemon thread. In multi-threading, you will understand what is daemon thread. So garbage collector is a daemon thread which is automatically scan the heap area. Automatically scan the heap area. Can you please write in the chat window? Garbage collector is scanning which memory area? Come on, write in the chat window, all of you. Garbage collector is scanning which memory area? All of you, I want answer from all of you. Which memory area? Heap memory area. Heap memory area. So garbage collector will only see or only visit heap memory area. Garbage collector will only visit this heap memory area. Please try to understand. So garbage collector is a daemon thread which is automatically scan the heap area and finding which objects are eligible for garbage collector. Which objects are eligible for garbage collector? Which objects are eligible for garbage collector? Okay, now which objects are eligible for garbage collector? So it will automatically scan the heap area. It will automatically scan the heap area and finding which objects are eligible for garbage collector. So actually, which objects are eligible for garbage collector? The object which does not contain any references. The object which does not contain any references. The object which does not contain any references, only those objects are eligible for garbage collector. Only those objects are eligible for garbage collector. Only those objects are eligible for garbage collector. Okay. Okay now. So only those objects are eligible for garbage collector. Only those objects are eligible for garbage collector, which does not contain any references. If the object does not contain any references, then automatically that object is eligible for garbage collector. I will explain more today only. Today I will give you the complete picture of this heap and stack diagram and garbage collection and everything. Okay. Then what is next, sir? Look. It uses an algorithm. It uses an algorithm that is mark and sweep algorithm. Mark and sweep algorithm. Mark and sweep algorithm to delete the unused objects. To delete the unused objects. Okay, now, if you have any unused objects, those objects are deleted. Those objects are deleted by what? Those objects are deleted by garbage collector. Unused objects. So it uses an algorithm that is mark and sweep algorithm. Mark and sweep algorithm to delete the unused objects. So what is the meaning? Look, what is the meaning, sir? What I want to say? What I want to say? Let's say here you have a heap memory. Okay, now here you have a heap memory. Please try to concentrate. Here you have a heap memory. Okay. In this heap memory, you have objects. You have objects. Let's say this is first object. Like that, you have multiple objects are there. You have multiple objects are there. Now, these objects are usable. Okay, here, space is not there. These objects are usable if these objects are having references. As long as the object is containing references, guys, as long as your object is containing references, it is not eligible for garbage collector. It is not eligible for garbage collector. Let's say this is what? This is OBJ1. This is OBJ1. As long as your object is containing object references, as long as your object is containing object references, it is not eligible for garbage collector like this. So all these objects are containing what? References. All these objects are containing what? Reference here, references. So obj1, obj2, obj3, these are the reference variable. These are the reference variable. And now you have total three objects. You have total three objects, and all these objects are referred by reference variable like obj1, obj2, obj3, obj1, obj2, obj3. So if garbage collector is visiting your program, if sir, when garbage collector will visit my program, it depends upon the threshold limit. Sir, what is threshold limit? So as I told you, heap memory is having some limited memory. Heap area is having some limited memory. So once your heap memory is filled up with 60 to 70%, then automatically JVM will make a request to garbage collector to visit the heap memory. Why? To delete the unused objects. So once garbage collector will automatically delete the unused objects, your heap memory will become free. Think why Java has given the name garbage. Why Java has given the name garbage collector. Java has given the name garbage collector because if an object does not contain any references, if an object does not contain any references, so we cannot use those objects. That object is no longer required. That object is no longer required because it is not containing any references. It is not. I'm telling you which objects are not containing any references. Give me a couple of minutes. So if the object is not containing any references, that means it is a useless object. It is a useless object, and unnecessarily it has stored my non-static field and non-static method. Unnecessarily, it is wasting my memory. So when garbage collector will visit, when garbage collector will visit, when garbage collector will visit based on the threshold limit of the set memory, or you can also call garbage collector by explicitly writing one code system.gc. System is a predefined class and GC is a static method. So you can also call garbage collector by using system.gc. By default, garbage collector will visit depending upon your threshold limit of heap memory. Okay. So when garbage collector is visiting to your program, then what garbage collector will see? It will scan the heap area and it will see which objects are eligible for garbage collector. So this object not eligible, this object not eligible, this object not eligible, this object is eligible because this object does not contain any references. This object does not contain any references. So this object is eligible for garbage collector. Garbage collector will delete this object from the heap memory. Once garbage collector will delete this object from the heap memory is free. And now more and more objects you can assign here. Tell me, everyone understood what is the purpose of garbage collector and why it is called garbage collector, which memory it is scanning, and which objects are eligible for garbage collector. Please write down. You understood all these points? Everyone, please write down. I'm requesting, please, all of you write down. You understood all these points, what I explained. Always your objects are storing in the heap memory. Garbage collector will visit only heap memory. Garbage collector will visit only heap memory. Now what garbage collector will see? Garbage collector will only see whether an object is eligible for garbage collector or not. Which objects are eligible for garbage collector? Which objects are eligible for garbage collector? The objects which does not contain any references, those are object eligible for garbage collector. Srikant, daemon thread means one kind of thread which is running in the background to provide the services for user thread. Daemon thread is a low priority thread, which is running in the background, to provide the services for user thread. Like main is a user thread. So now to provide some services, some sort of services to user thread, we are using what? We are running garbage collector in the background. That means daemon thread is running in the background. Low priority thread. Okay, now? Yes, you can say relocation to clean unreferenced object. Absolutely. Okay. Sir, how many ways we can make an object eligible for garbage collector? Look, how many ways we can make an object eligible for garbage collector? How many ways we can make an object eligible for garbage collector? How many ways are there to make an object eligible for garbage collector? So let's see here. There are three ways. There are three ways to make an object eligible for garbage collector. There are three ways to make an object eligible for garbage collector. Now, there are three ways to make an object eligible for garbage collector. Number one, assigning null literal to the existing reference variable. You know, assigning null literal to the existing reference variable. In the existing reference variable, if I assign null, then object is eligible for garbage collector. Sir, what is the meaning? What is the meaning? Look, sir, meaning is what? Let's say here I have created one object. Please concentrate, all of you. It's very, very important. I have created one object. Hold your question at last. You ask me, I will answer. Employee EMP is equal to new employee. Everyone tell me what will happen internally. Internally, one employee object will be created at 1000x memory location. Say yes or no. Everyone, please write in the chat window. Internally, what will happen from your last class knowledge? What you learn? Employee EMP is equal to new employee. What will happen internally? Internally, one object will be created. Internally, one employee object will be created at some memory location like 1000x. So let's say here one memory is created. Think here, let's say one object is created. Sir, what is that object? That object is employee object. Employee object. This employee object is created at 1000x memory location. Sir, what it is containing? It is containing ID, properties. Initially it was 0, now it modified to 100. And it is containing name. Initially it was null, now it is containing Scott. And this object is referred by EMP reference variable. This object is referred by EMP reference variable. Tell me, everyone understood up to here? Come on, come on, come on, write in the chat window. Everyone understood up to here? Please write quickly, quickly, quickly. Super, super. Please write quickly, guys. Understood everyone here? Come on, come on, come on. Yes. So here one object is created. That object is containing two properties. One is ID. ID value is 100. Name is what? Scott. Name is a Scott. ID is 100. Name is a Scott. Great. This is the same thing. This is the same thing we have created. We have learned in the last program. Okay. Then after that, what you are doing, guys? After that, what you are doing? After that, in the second line, learn carefully. Today's class is very, very important. After that, in the second line, you are writing EMP is equal to null. EMP is equal to null. What is EMP? EMP is a reference variable. EMP is a reference variable. It is an ordinary variable. So it can hold only one value at a time. It is not an array variable. It is not an array variable. Your array variable can hold multiple values. Your array variable can hold multiple values. What it is? It is an ordinary variable, ordinary reference variable. So how many values it can hold? It can hold only one value at a time. So EMP can hold only one address. Look, EMP can hold only one address. So it is pointing to 1000 address. 1000x address right now. The moment you have written EMP is equal to null, now what will happen? This EMP will point toward, this EMP will point to null. This EMP will point to null. Now, once it will point to null, what will happen? The old reference is deleted. It is now deleted reference. It is now deleted reference. This is deleted reference. This reference is not available. It is deleted because EMP is pointing to null. Deleted reference. Then tell me, it is a deleted reference. Then tell me, right now, any reference variable is pointing to this employee object which is created at 1000x memory location. Come on, write in the chat window. I want answer from all of you. This object is referred by any of the reference variable right now. Anyone is referring to this employee object? Come on, quick. Super. Excellent. So no one is referring. Meanwhile, look, no one is referring. So now you think, suppose garbage collector is visiting to your program, guys. Suppose garbage collector is visiting to your program. Then what garbage collector will see? Garbage collector will see, array, this object is not referred by any of the reference variable. Then what garbage collector will tell to this object? Object, your life is completed. You pack your luggage. Your life is completed. I'm coming to visit more objects in the heap memory. So what garbage collector will do? Garbage collector will mark this object that your life is completed because no one is referring you. You are useless. You are garbage for Java. Right now, you are garbage for Java. And give me some time so I can visit more objects, whether those objects are also eligible for garbage collector or not. Like that, garbage collector is visiting your heap memory. While visiting, it is going to mark which objects are eligible. Which objects are eligible means those objects which are not containing any references, like this object, not containing any references. So garbage collector will mark this. And then it will visit another object inside the heap memory. Remember, garbage collector only visiting the heap memory, nothing else. Garbage collector is only visit heap memory. You have method area memory, you have a stack end area memory, but garbage collector will only visit heap memory. Then after marking all the objects, while going back, it will collect the objects. That means it will delete the objects from that particular heap memory. So your heap memory will become free. Tell me, everyone, understood all of you? Everyone, you understood? Null means nothing, Srikam. Null means nothing. Okay, null is a literal. Okay, great. So this is the first thing. How you can make an object eligible for garbage collector. Now I'm going to second point. I'm not giving any notes. I will give you the notes after the end of the session. Look, second point. What is the second point? Sir, creating an object inside a method. Creating an object inside a method. Sir, what is the meaning? Look, suppose I'm going to create an object, public void create object. And inside this method, I'm going to create one object. Let's say student S1 is equal to new student. Can you answer me what is S1? Can you please answer me what is S1? Can you please write in the chat with all of you? What is S1? What is S1? S1 is a local reference variable. S1 is a local reference variable. S1 is a local reference variable. Then what will happen? Look, here also one object is created. All of you, here also one object is created. Please concentrate. Here also one object is created. Sir, what is that object? That is a student object. Here also one object is created. That object is the student object. Student object is created. The .student object is created, let's say, at 3000x memory location. Now, who is referring to this student object? The S1 reference variable is referring to this student object. S1 reference variable is pointing to this student object. Okay. Now, what is S1? S1 is a local variable. S1 is a local variable. So what will happen when you call this method, when you call this method, when you call this method for this particular method, for this particular method, internally one stack frame will be created. Whenever we are calling any method in Java, internally one stack frame is created for each and every method. Every time we are calling a method in Java, one stack frame is created for each and every method. Okay. That what that stack frame is containing? It is containing all the local and parameter variables data. Actually, it is containing local variable array, frame data, and operand stack. Every stack frame is containing three things: local variable array, frame data, and operand stack. Technically, it is containing local variable as well as parameter variable. Now you tell me, once this method execution is over, then what will happen? Once this method execution is over, this S1 variable will be deleted from the frame. This S1 variable will be deleted. This method execution is over. Once method execution is over, this S1 frame will be deleted from the frame. Once S1 will be deleted from the frame, once S1 will be deleted from the frame, now no any reference variable is pointing to this object. No any reference variable is pointing to this object. In that case, what will happen? This object is eligible for garbage collector. This object is eligible for garbage collector. So as soon as your method execution is over, this S1 variable will be deleted from the stack frame, from the corresponding stack frame. Once it is deleted from the corresponding stack frame, now no one is referring to this student object created at 3000x memory location. As a result, this object is eligible for garbage collector. So remember, whenever you are creating any object inside a method, that reference variable, that local reference variable life is within the same method body execution. Once method body execution completed, that local variable will be deleted from the frame. Automatically, object will become garbage collector, eligible for garbage collector. Okay, sir. Point number three. Point number three. This is very, very important. Point number three. Look, assigning assigning a new object, assigning a new object to the existing reference variable. Existing reference variable, assigning a new object to the existing reference variable. Now, what is this? So this is what, look, what is this? Let's say I have created one object. So what object I have created? Let's say I have created customer C1 is equal to new customer. Customer C1 is equal to new customer. This object I have created. Suppose here 101 and here let's say Raj. Oh, great. Object is created. Once object is created, you know very well what happens. One object will be created internally. In the heap memory, one object will be created. What object it is? It is a customer object. This customer object is created, let's say 7000x memory location. Customer object. Customer object. This customer object is created at 7000x memory location. And what it is holding? Let's say it is holding customer ID. What is the customer ID? Customer ID is 101. Customer name. What is the customer name? The customer name is Raj. Great. Now, this object is referred by which reference variable? This object is referred by C1 reference variable. C1 is pointing to this object. Okay. Then what happened? Look, what happened? You are saying in the next line, what you learn, shallow copy and deep copy yesterday. Deep copy, I will explain. Shallow copy, you learn. In the next line, you are saying, guys, in the next line, you are saying, what you are saying in the next line? In the next line, you are saying C1 is equal to new customer. C1 is equal to new customer. Let's say 111 and a Scott. Then what is the meaning? A Scott. What is the meaning, sir? The meaning is what? One new object will be created. One new object will be created. Look, one new object will be created here. It is also customer object only. It is also customer object only. One new object will be created, customer object. That this customer object is created at 9000x memory location. What this customer object is containing? It is containing ID. What is the ID value? ID value is 111. And name. What is the name value? The name value is spot. And now you tell me, this C1, all of you, please look at this one very, very carefully. This C1, which was pointing to 7000x memory location here, the C1 which was pointing to 7000x memory location here, now the same C1 is pointing to another object. So same C1 is pointing to another object. So this C1 is now pointing to another customer object which is created at 9000x memory location. So what will happen? Automatically this object will become eligible for garbage collector. Now, can you please write in the chat window if your garbage collector is going to visit your heap memory, then which object is eligible for garbage collector? 7000x object is eligible or 9000x object is eligible for garbage collector? Please write in the chat window which object is eligible for garbage collector, 7000 or 9000? All of you, I want response from all of you guys. It is my request. Please write in the chat window which object is eligible for garbage collector. Garbage collector will remove which object? Very good, excellent. The chat is booming. Very good, excellent. So garbage collector will delete the 7000x memory location. Why? Because this 7000x memory location is not referred by any of the reference variable. Okay. So these are the three ways how you can make an object is eligible for garbage collector. By writing your code, you can make an object eligible for garbage collector. Very good. Now let me introduce the most demanding and most useful concept, the most beautiful concept of Java, heap and stack diagram. Heap and stack diagram. Heap and stack diagram. Okay, now most powerful concept. Sir, what will happen if we learn this heap and stack diagram? First of all, the first benefit is what? Learning of heap and stack diagram, the first benefit is what? You will get the complete object visualization. How exactly object is working internally, what happens, the complete visualization you will get. Within couple of minutes, I will give you the complete visualization. Second point, you will understand a clear-cut idea of heap and stack diagram. What is heap, what is stack, how they are connected to each other. How they are connected to each other. And the last one and the most important, after learning heap and stack diagram, any complex to complex program output you can easily tell. Any complex program is there, very complex program is there. I will show you the complexity level of the program. I will show you the complexity level of the program. Okay. So that complex program output you can say easily. Look, if I show here, what type of program we will learn in this heap and stack diagram. Java, if you go to garbage, look, what is the complexity level? What is the complexity level? This is one program, let's say sample. This is the complexity level. This is the complexity level. Okay, now this type of complex program we will learn. This type of complex program we will learn and we will see what is the output of this program. We will see what is the output of this program. Extraordinary concept it is. So please reply in the chat window. You guys are ready? Yes. Automatic memory management means what? You need not to deallocate the memory, Tanvir. Of course, you need to take care of your memory. Come on, tell me. You guys are ready? Should I start? Heap and stack diagram. Great, great, great. I love the response. Chat is moving right now. Look. So guys, let's say I am going to give you the idea of heap and stack diagram. So first, let's say I'm going to give you a small idea. Small idea. Okay, before that, a quick small idea. Look, memory in Java. So memory in Java means what? Quickly. Again, memory in Java means what? You need not to repeat. Just what I explained already, just you go through that point. That is more than enough. What are the point? Look, Static fields are available in method area. Non-static fields are available in heap area. Local and parameters are available in stack area. Okay, now? Okay, now? Okay. Good. Very good. Excellent. 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 Now let's say we are going. Okay, now let's say. So I think one student is having what doubt, what doubt, what doubt. Wait, Tanvir. Tanvir, you are not. Please try to understand what I'm trying to say. You. I'm saying what it is a automatic memory management. We have automatic memory management. Automatic memory management means what? Automatically your heap memory will take care. Automatically garbage collector will take care of your heap memory. You need not to take burden. In C++, you have to take the burden to delete the objects. But in Java, it is not your burden. Automatically, it is taken care by garbage collector. That is the beauty of Java. Okay, anyhow, I hope you understood. Now let me go to the heap and stack diagram. So just let me give you one first simple basic example. And based on that, I will explain. So let's say here I'm taking one class, public class customer or public class, let's say student. Okay. Then here int roll is equal to or int marks is equal to, let's say 90. Okay. Then here I'm taking what main method, public static void main string of args. Inside this main method, I'm taking what int val is equal to 500. Or let's say int val is equal to 500. Okay. Then here I'm writing what student S1 is equal to new student. And in the next line, again, I'm writing S1 is equal to new student. Oh, great. Main method is closed, class is closed. Sir, my file name is student.java. My file name is student.java. So remember, look, whenever we compile and execute any Java program, like my file name is what? Student. My file name is student. What is my file name? Student.java. Student.java. So whenever I will compile and execute any Java program, Java C student.java. Okay. Then Java student. Java student. Look. So whenever we are executing our Java program, look, at the time of execution, JVM will get at the time of execution of our Java program, JVM will get some memory. JVM will get some memory. JVM will get some memory from the operating system. JVM will get some memory from the operating system. That memory is divided. That memory is divided into two sections. Look. So one is what? One is heap memory. Another one is what? Stack memory. You know? Now, heap memory comes under meta space. Whenever you have a free time, learn what is meta space. Earlier it was permgen, PERMGEN. But now we have meta space. Meta space means more dynamic, more dynamic. So now inside your heap memory only, so many things are there and it is dynamically growable as well. Please learn whenever you have a free time. What is meta space in Java? In terms of memory, you will get more clarity. So heap memory and stack memory. So here also what will happen? When I compile and execute this program, I will get, I will get what? I will get two memory. One is heap memory, another one is stack memory. Look, heap memory, stack memory. What heap memory is going to store? Heap memory is going to store only objects. What stack memory is going to hold? Stack memory is going responsible to execute your Java methods. In a stack frame, every method is having their own corresponding stack frame. Okay. So now you can see here that our program execution will start from main method. Our program execution will start from main method. So as soon as my main method start, or as soon as my main method will start executing, guys, this is extraordinary concept. Extraordinary concept. Please keep patience and please learn very carefully. This will give you a confidence to tell you any program output. In a 5 to 10 minutes, you will understand what is the power of heap and stack diagram. So here, my first method is what? My first method is what? Main method. So main underscore stack. Main underscore stack means what? My main method stack frame is started executing. Let's say I have main M1 and M2 method. I have main M1 and M2 method. I have main M1 and M2. Assume that. Another example. So what will happen? You have three stack frame. First stack frame name is main stack frame. Second stack frame name is what? M1 stack frame. Okay, now. Then third stack frame name is what? M2 stack frame. Every time you will call a method, a new stack frame will be created for that corresponding method call. Okay, so here we have only one main stack. Now, under this main stack, look, under this main stack, what is going on first? The first thing you can see inside this main method. Actually, if you talk more, then the first thing in this ARGS, in this first main method, when you are executing main method, the first variable is ARGS. The first variable is ARGS. But this ARGS variable will active when you are using command line argument. This ARGS variable will become active when you are using command line argument. If you are passing some value at runtime by using command, then this ARGS variable is going to hold the values. But right now, I'm not passing any command line values, command line argument. So I'm considering my val as my first variable. So now you tell me, all of you, what I'm asking. Just you tell me, val is a what type of variable? Come on. I want all of your involvement. Val is what type of variable? Primitive or reference? No. Primitive or reference? Val is a what type of variable? Primitive or reference? Primitive or reference? Primitive or reference? Yes, primitive. Absolutely correct. Now, method level variable or class level variable? Just answer my question. Method level variable or class level variable? You have declared inside method or inside class? Method. So in method, you have two variables. One is parameter, one is local. It is what? It is a local variable. It is a local variable because you have not declared inside what? Parameter, method parameter. It is a local variable. And most important, it is a primitive. So primitive will directly hold the value. What I explained yesterday. Primitive will directly hold the value. Val colon 500. Val is a primitive variable. Val is a primitive local variable. So it is directly holding the value. Great. Then go to the next slide. This line is completed. Go to the next line. Next line is what? Student S1 is equal to new student. Student S1 is equal to new student. What is S1? S1 is a local variable, local reference variable. S1 is a local reference variable. S1 is a local reference variable. Local reference variable. So reference variable will hold value? No. Then what reference variable will hold? Reference variable will hold address. Reference variable will hold address. What I explained yesterday. Reference variable will hold address. Sir, where address, sir? Where address? So look, actually you can see here, an object is created for a student. An object is created for a student. For this particular object, where object will be created? Object will be created in the heap memory. Object will be created in the heap memory. So let's say at 1000x, you have one object created. What is that object? Student object. Now, whenever you create student object, it is the universal truth of Java. What? Whenever you create the student object, all the non-static fields are getting the memory as well as initialized with default value, later with user value. So if you are creating 5 student objects, then 5 separate copies of non-static field will be created. 5 separate copies of non-static field will be created. So here you are creating the first student object. Then what will happen? With this student object, one non-static field marks. then marks value will be what? 90. 90. This object is created at 1000x memory location. Whenever you are creating the object, non-static field will initialize with default value, then with user value. And now this S1 is pointing to this 1000x memory location. This is called heap and stack diagram. This is called heap and stack diagram. Look, it is pointing to 1000x memory location. That is the beauty of heap and stack diagram. Okay. Just one example I have given to you. Everyone understood this one? Can you please clear? Can you please confirm in the chat window so I can move forward? Everyone understanding. It is a top level concept. Everyone understanding? Please write in the chat window. Why I have created this 1000x student object in the heap memory? Because objects are stored. Objects are always stored in the heap memory. Always are stored in the heap memory. What about this S1? S1 is a local reference variable. S1 is a local reference variable. Local variables where they are stored. They are stored in the within the same stack frame. So S1 is a local variable of main method. So in the main stack frame, this local variable will be available. In the main stack frame, this local variable will be available. Is it clear to all of you? Sir Kailas, marks value you are directly initializing with 90. Marks value you are directly initializing with 90. That's why. That's why here 90. That's why here 90. Marks value you are directly initializing with 90. You can also initialize through constructor. Wait a couple of minutes. I will explain in another program. Okay, sir. Great, great. Sir, this line is completed. This line is completed, sir. Now move to next line. Next line is this line. Look, next line is this line. Here, what you are saying, here you are saying another object is created. You are creating a new object. You are creating a new object. Then what will happen internally? Internally, look, internally what will happen? At 2000x, another student object will be created. Another student object will be created. But whenever this student object will be created, non-static field and you have initialized with fixed value 90, so marks is what? 90. This is new object. This is new object, another object created in another memory location. Created in another memory location. And this object, this newly created object is created at 2000x memory location. Now you can see here, this newly created object, you are assigning to S1 reference variable. You are assigning to S1 reference variable. That means what will happen? This S1, which was pointing to 1000x, the S1 which was pointing to 1000x, the same S1 will point to now 2000x. So what will happen? Now this S1, which was pointing to 1000x, it will change to 2000x. So this is very basic program of heap and stack diagram. If you understood, then I can go. If you understood, then I can go to the advanced program. Advanced program is more important programs. You understood the basic foundation of heap and stack diagram. Tell me, then I can go to the another programs. Everyone understood? Can I move to another program? Another program is it is the demo purpose only. Main program is coming. Everyone understood? Can I move? Come on, write in the chat window. Perfect, excellent. Excellent, you guys are. I will talk a lot of times, Srikant, just to try to concentrate. Now look, I'm going to show your first heap and stack diagram program. My first heap and stack diagram program, I'm going to explain. What is that? Customer demo.java. Look, first heap and stack diagram program, I'm going to explain. String pool is available in the string constant. Now, why you are asking this type of question in the middle? String pool is now the part of heap memory after from Java 7. Are you creating any string object here, Sairam? What you are thinking? Java is possible in a single day? Come on, guys, concentrate on the current topic. Concentrate on the current topic, sir. String constant pool means if I start giving you the idea of string constant pool, we will divert from the original topic. Okay, let's see. So you can see one small program is there. One small program is there. Okay. So what is that program? Look carefully, all of you. One small program is there. Very simple program. Class customer, class customer, and then you have two non-static fields. Class customer, you have to, after learning this heap and stack diagram, I am giving you the guarantee. Any interviewer will ask you, can you tell me something about this program? Can you tell me the output of this program? Without looking the program, you can say, yes, sir, I can tell the output because I have that much of confidence. Please try to concentrate on the current topic. So you have two non-static fields. One is name, another one is ID. You have two non-static field, name and ID. Obviously, to initialize, we are having what? Parameterized constructor. By using this parameterized constructor, I am initializing this name, I am initializing this ID. Great. This parameterized constructor to initialize both the non-static field. Then here I have taken one setter. I have taken one setter to modify the value of ID. And here I have taken what? Getter to read the ID value. To read the ID value. Very simple program. One constructor, setter, getter. Setter will modify the value of ID. You can modify the value of ID and getter will give you the ID value outside of this BLC class. Okay. Then here int val is equal to 100. We will see. And customer C is equal to new customer. M1, M1 of C. We will see in more detail. Wait. Just I am giving you the overview. Then GC system.out.println c.getID. Here you can see customer object I am passing as a parameter variable. Then cust.setID, another object, set ID, and then what? Get ID. This is what complete program. This is what complete program. Now let me create heap and stack diagram for customer demo.java. Create heap and stack diagram program for customer demo.java. Heap and stack diagram for customer demo.java. Heap and stack diagram for customer demo.java. So when you will execute this customer demo.java, you will get two memories. One is heap memory, another one is stack memory. Heap memory where all the objects are going to be stored, and stack memory where methods are going to be executed. Now, great. So go to your first main method. Where is main method? Here is my main method, main method, main method. Here is the main method. Okay. As usual, what is my first variable? My first variable is args, but it is not active. Why it is not active? Why it is not active? Because it is not a command line argument program. It is not a command line argument program. So that's why it is not active. So my first variable is what? Val, whose value is 100. My first variable is what? Val, whose value is what? 100. Now tell me, val is a primitive or reference? Val is primitive or reference? Come on, write in the chat window. Just you write P or R. No need to write. P is primitive, R is reference. So tell me, it is P or R? Primitive. Primitive. Great. Great. Excellent. So what will happen? The moment you call this main method, in the stack memory, one main underscore stack will be created. Here, main underscore stack will be created. Main underscore stack will be created. Okay, now this is what? A stack frame for main method. A stack frame for main method. Only for main method, a stack frame is there. Here you have first variable is val, which is a local variable, primitive variable, and its value is 100. So val colon 100. Val colon 100. Colon means how it is represented in memory. Why I'm taking this colon? It is represented in memory by using colon. Okay. Okay. Next. Next, you can see here, next, customer C is equal to new customer Ravi, comma 2. Concentrate everyone. Customer C is equal to new customer Ravi, comma 2. Sir, what is the meaning of this line? Sir, you are creating one customer object. You are creating one customer object. Sir, what about this C? Sir, C is a local reference variable. C is a local reference variable. So where this object will be created? This object will be created in the heap memory. Where this C variable is available? This C variable is available in the stack memory in the main stack frame. Okay. So first you create the object, new customer. First you create the object, new customer. So I'm going here, I'm creating the object, new customer. Look, how to create the object at 1000x memory location. You can take any memory location, but I am generally taking 1000x. 1000x memory location. 1000x memory location. Look, customer object will be created. Customer object will be created. Customer object will be created. Now, what is the universal truth in Java? Whenever you create the customer object, all the non-static fields are getting the memory with the help of new keyword, as well as they will initialize with default value, like name will become null and ID will become 0. So with the new keyword, they will what get the memory, and then with the help of constructor, they will get their user defined value. So here we have name, initially null, I'm not writing null, and comma, here we have ID. Great. Guys, whenever you will create the object for customer, these two non-static field will be created with each and every object. Okay, great. Then, sir, you tell me. Now, name and ID, you are going to initialize through parameterized constructor. What is the value of name? Ravi. What is the value of ID? 2. Name value is Ravi, ID value is 2. So from here, look, this name, parameter variable name will become Ravi, ID will become 2. And with the help of parameter variable, you are initializing your non-static field. So ultimately, this name will become Ravi and ID will become 2. Now you come. Now you tell me, I want answer from all of you. ID is a primitive or reference? ID is a primitive or reference? Look here, ID is a primitive or reference? Srikant, I'm not talking about instance variable. Variables are only two types, primitive or reference. ID is primitive or reference? ID is primitive or reference? ID is primitive. Once it is primitive, what it will do? It will directly hold the value. What is the value? The direct value is 2. The direct value is 2. The direct value is 2. Okay. ID is primitive. ID is primitive, so it is directly holding the value. What is name? Name is primitive? No. Name is reference. Name is reference. Sir, name is not primitive, sir. Name is reference, sir. So name is reference. Then what will happen? Name will not hold value directly, Ravi. Don't think like that. It will directly hold the value, Ravi. No, no, no. Then what will happen? This name will point to another memory location, let's say 2000x. And what 2000x? Actually, it is your SCP area, string constant pool area. Right now, I'm not talking about string constant pool. Otherwise, I will divert from the original topic. So in the 2000x, now string constant pools are the part of heap memory only. String constant part, string constant pool is the part of heap memory only. Whenever you have a free time, search in the Google or search in the chat GPT. Now, string constant pool are from which version of Java string constant pools are the part of the heap memory? You will get the answer. So at 2000x, what happens, sir? In 2000x, a string object is created, sir. And that string object is containing the value Ravi. Sir, why it happens, sir? Because name is a reference variable. Name is not primitive. Reference variable is holding the address. Primitive variables are holding directly value. Tell me, everyone understood? Then only I can proceed. Everyone understood? Great. Excellent, guys. Excellent. Now, what object you have created? This object you have created, that object you are assigning to this C variable. C is a local reference variable. C is a local reference variable. So here in the main underscore stack, you have a C. This C is pointing to 1000x memory location. Because C is a local variable. C is a local variable. So C is pointing to this object, which is created in heap memory. Great. Excellent. After that, after completion of line number 30, then you are calling one method M1. You are calling one method M1. Look, M1 is what method? M1 is a static method. So can I directly call from the main method? Yes, because M1 is a static method. M1 is a static method. Sir, M1 method, I'm passing C. C is a reference variable of type customer. C is a local reference variable of type customer. Then M1 is method is also taking CUST variable of type customer. Okay, CUST is the parameter variable. CUST is the parameter variable. So you tell me, can I assign this C to this CUST? Right in the chat window. Can I assign this C to this CUST? And if I'm assigning, it is cello copy. Is it a cello copy? Is it a cello copy? Yes, it is a cello copy. It is a cello copy. But look, this M1 method is another method, sir. This M1 is another method. M1 is another method. Look at the beauty of Java. So what will happen? What will happen? Again, Java will call another stack called M1 underscore stack. It is another stack, but in the same stack memory. It is something like this. It is something like this. You call one method M1, you call one method main, and again you are calling one method what M1. Two frames are created in your stack memory. So M1 underscore stack, one frame is created. M1 underscore stack, one frame is created. Now in this M1, look, control has successfully jumped. Control has successfully jumped from main to M1. Control has successfully jumped from main to M1. Now in this M1 method, in this M1 method, in this M1 method, in this M1 method, all of you, in this M1 method, what you are passing this C, and this CUST is your first variable. CUST is your first variable. All of you concentrate. So what will happen here? Your first variable name is CUST. Your first variable name is CUST, and in the CUST, what you have assigned? You have assigned C. That means you have assigned 1000x. Please look here, all of you. This C is pointing to 1000x, and this CUST is also pointing to the same object 1000x. That is called cello copy. That is cello copy, what you learned yesterday. That is cello copy, what you learned yesterday. Okay, great. That is cello copy, what you learned yesterday. Okay, sir. Move. Then you are saying cust.setID5. cust.setID5. Now you are calling one setter encapsulation. You are calling one setter encapsulation to modify the value of ID. To modify the value of ID. To be very frank, whenever you are calling this setID method, again for this setID method, you need to create one stack frame separately. For this setID method, you need to create one stack frame separately. But you know, setters are mainly used to modify your existing object data. It will modify your ID value. So there is only one purpose. So I'm not creating a separate stack frame, but actually, in reality, you should create one separate stack frame. Then what I'm doing? I'm calling this setID and I'm modifying the value of ID to 5. So look, CUST, what you have written here, CUST.setID5. CUST.setID5. Let me copy up to here. It would be more better. Wait. Let me copy up to here. Just wait. And I'm pasting here. Look. So we can save some time. Look, right now we are here. Right now we are here. CUST.setID5. 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 CUST. CUST, which is pointing to 1000x. CUST, which is pointing to 1000x. That value you want to change to ID. ID value you want to modify to 5. Then tell me what will happen. What will happen? This value 2 will modify to what? 5. This value 2 will modify to 5. Please keep patience. That is the beauty of Java. The value of 2 modified to 5. Okay. The value of 2 modified to 5. Okay, sir. This line is over. This line is over, sir. Now you are saying CUST is equal to new customer Rahul, comma 7. This line. CUST is equal to new customer Rahul, comma 7. So tell me, due to this, what will happen? One new object will be created. One new object will be created in the heap memory because you are creating another object. So at 3000x, one new customer object will be created. One new customer object will be created, and this customer object is again containing what? Name and ID. That is the universal truth. Whenever you create object, multiple copies of non-static field will be created with each and every object. Okay. Then what is the value of ID? ID value is fixed 7. You know, primitive will directly hold the value. Primitive will directly hold the value. What about this name? Sir, name is a reference variable, sir. Name is a reference variable. Reference variable means what? It will hold 4000x. The guys who are having the knowledge of string constant pool, then I can just give you one small mantra. If you have a knowledge of string constant pool, then by chance, if you don't have here Rahul, if you have Ravi, suppose instead of Rahul, if you have Ravi, then what will happen? This name will point to same 2000x memory location because string constant pool does not contain duplicate objects. So suppose in place of Rahul, if you have Ravi, then same Ravi, that means name will point to same 2000x memory location. But here the scenario is different. Here you are taking another object, another string constant pool object, that is Rahul. So what will happen at 4000x? One new string object will be created. At 4000x, one new string object will be created. One new string object will be created. And now this string object value is what? This string object value is Rahul. And please look very, very carefully what this newly created object you are assigning to CUST. This newly created object you are assigning to CUST. So CUST, which was pointing to 1000x, now the same CUST will point to what? 3000x. Same CUST is pointing to 3000x memory location. And now you told that this line is also over. This line is completed. Great. Now you are saying, look, this line, you are saying CUST.setID 9. Again, you want to modify the value of ID with 9. Then tell me, all of you, tell me now which ID will modify? Which ID will modify? 7 will modify or 5 will modify? 7 will modify or 5 will modify? You guys are excellent. You guys are excellent. I love the way you are booming right now. Chat is booming. You guys are excellent. Everyone is giving the right answer. Not a single person has given the wrong answer. Happy, happy, happy. So yes, because this CUST is pointing to 3000x, because this CUST is pointing to 3000x right now, that's why this 7 value will modify. This 7 value will modify to 9. Based on that, output will come, guys. Based on that, output will come. Okay. Now this line is over. This line is over. Okay. Then system.out.println cust.getID. GetID means you want to print the value of ID. cust.getID. CUST is pointing to 3000x. What is the value of ID? ID value is 9. You tell me what is my first output? My first output is 9. My first output is 9. Everyone understood? Please write in the chat window. Just write why. I will understand you understood. Excellent, guys. Excellent. Excellent. Rocking you guys are. So now you come back here. Look, this method is over, sir. This method is over. Hello. This method is over. This method is completed. Once this method is completed, then what will happen? This method will be deleted from the stack frame. LIFO, last in, first out. The method will be deleted from the stack frame. This method will be deleted from the stack frame. Okay, now M1 method execution is over, so it is deleted from the stack frame. Let me write here. M1 method execution is over. So it will be deleted from the stack frame. From the stack frame. It will be deleted from the stack frame. Great. Now your control return back to main method. After the execution, this execution is completed. Your control return back to main method. Your control return back to main method. You are in now main method. Look, this method execution is over. You are in the main method. You are in the main method. You return back from here. You call the M1 method. From line number 32, you call the M1 method. You return back here. Now interviewer is asking one question to you. Interviewer is asking one question to you. What question? When your control will reach to line number 34, when your control will reach to line number 34. And if that time your garbage collector is visiting your program, in that time garbage collector is visiting your program, your heap memory garbage collector is visiting, how many objects are eligible for garbage collector? How many objects are eligible for garbage collector? So you can see here, hello, you can see here how many objects are eligible for garbage collector. So you can see here, from here, you can point because this is already deleted. Frame is already deleted. So from here, you can only reach to 1000x. That means 1000x is not eligible for garbage collector. Still, you can use this 1000x. So even garbage collector is visiting your program, garbage collector cannot delete this 1000x object. Then what about 2000, 3000, 4000? Guys, string objects are never eligible for garbage collector. Strings are very super object in Java. They are kept for reusability purpose. So only one object, string objects are never eligible for garbage collector. String objects are never eligible for garbage collector in Java. So that means only one object is eligible for garbage collector. That is what? 3000x. Sir, I am deleting this 3000x. Then what about this Rahul, sir? What about this Rahul? What is the use of this Rahul? No, this Rahul is meant for reusability purpose. After some time, if someone is writing string x is equal to Rahul, string x is equal to Rahul, so your x variable will directly point to this 4000x. That is Java beautiful. Beautiful Java. So this x will automatically point to this 4000x for reuse this Rahul object. JVM will not create another Rahul object in the string constant pool. It will same Rahul object is referred by this x variable. That means x variable is pointing to this 4000x. Now, if you go more depth, then string is internally containing character array. That means one more layer of object is there. But I don't want to go that much of depth. Otherwise, every string is a collection of character array. Then again, character array. Character array is an object. Array is an object in Java. Internally, one more memory diagram will be created. But anyhow, you will get the output from here without creating that. Then tell me, all of you, how many objects are eligible for garbage collector? How many objects are eligible for garbage collector? Remember, string objects are never eligible for garbage collector for reusability purpose. Okay, so only one object, that is 3000x, is eligible for garbage collector. Only one object, that is 3000x, is eligible for garbage collector. Only one object, that is 3000x, is eligible for garbage collector. Great. Then last line of the program, system.out.println c.getID. C.getID. Sir, C means what? C means what? You are pointing to 1000x. C means you are pointing to 1000x. 1000x, what is the value of ID? ID value is 5. ID value is 5. So my next output is what? My next output is 5. Then tell me, if I compile and run this program, if I compile and run this program, what is the output? The output is 9 and 5. If I compile and run this program, what is the output? The output is 9 and 5. The output is 9 and 5. This is your first heap and stack diagram, complete diagram. This is your program and this is the diagram. Tell me, you enjoyed, you understood. We will learn 3-4 programs. You understood. That is what power of Java. That is the power of heap and stack diagram. That is the power of Java. That is the power of heap and stack diagram. Everyone understood or not? Today I will give you the notes as well. Okay, great. 1000x is still referred by main method, no? Actually, why 1000x is not eligible for garbage collector? Because your main method is not completed, sir. Your main method is not completed. Where your main method is going to complete? Your main method is going to complete at line number 37. At line number 37, your main method is going to complete. So here only garbage collector has visited your program. When garbage collector visited your program, that time main method is not completed. Main method is not completed. This from main method still you are pointing to 1000x. So garbage collector cannot delete this 1000x. Is it clear to all of you? Can I move to next program? One more interesting program. Come on. Can I move to another program? Is it clear? So I can tell you. Yes. You guys are excited? Just write in the chat window. Just write E. Are you excited? Should I write one more program? Come on. Yes. Very good. Excellent. 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 Yes. Yes. Very excited. Yes. I am also excited. I am also excited. Look, one more program which will definitely give you high level of concept to understand this heap and stack diagram. Very beautiful program. Please try to concentrate, all of you. So let's see heap and stack diagram on employee.java. Heap and stack diagram on employee.java. Last program of the day. So please concentrate. Look at first overview of this. Overview of this, please. What is the overview? So public class employee int ID is equal to 100. ID is a non-static field. So whenever you will create employee object, this ID, multiple copies of ID will be created with each and every object. Here you have a main method. Val is a local variable, local primitive variable. You are creating one employee object. So whenever you will create employee object, of course, this ID value will be 100 always. Even.id is equal to val update system.out.println even.id employee e2 is equal to new employee another object e2.id switch employees very important switch employees in the switch employees you are passing e2 comma e1 sir where is this switch employees method is here and it is taking two parameter variable e1 and e2 look this is the path of learning copy constructor if you strong in this concept copy constructor will become fun for you copy constructor will become fun for you. Okay. Then we will see what is going on here. So many manipulations are there. Then we will see all those things and then garbage collector, how many objects are eligible for garbage collector and all those things. So let's start heap and stack diagram for employee.java. Heap and stack diagram for employee.java. Heap and stack diagram for employee.java. And guys, it will not take much more time if you draw in pen and paper. Here I need to draw in paint diagram, so it is taking a little time. But when you have a practice, no, when same thing I am drawing in the paper, no, it is hardly taking 1 or 2 minutes, just based on your practice. So again here, heap memory as usual, stack memory. You know very well that the execution of the program will start from the main method. So here main underscore stack. Main underscore stack. Great. Now, so let's begin with the main method. So main method, again, args is my first variable, but that variable will active when you are using command line argument. So we are not using command line argument program. Int val is equal to 200. Val is a local variable and local primitive variable. So it will directly hold the value. Val 200. So here val 200. Val colon 200. Okay. Next, employee E1 is equal to new employee. You are creating one employee object. Whenever you will create employee object, always the ID value will be what? 100. So let's create one object, employee object. At 1000x, employee object will be created. 1000x. This is the colon means how we are representing in memory. Employee object will be created. And you know, whenever employee object will be created, always the ID value would be 100. And why it is holding 100? Because ID is a primitive variable. ID is a primitive variable. So it is holding the value directly. If it is a reference, then it will hold address. Okay, this object is created. Who is holding this object? This object is referred by E1 reference variable. E1 is a local primitive variable. Local reference variable. So here E1 E1 will point to 1000x. Great. Now, line number 9 completed. Line number 11. Line number 11, E1.id is equal to val. Val value is 200. Val value is 200. You want to assign on even.id. Even.id. Even is pointing to 1000x. What is the value of ID? 100. 100 will change to 200. Because val value you are assigning to ID. Local variable value you are assigning to non-static field. Go. Very good. Then you are calling one method update. Look, whenever you are calling any method, first thing what you will do, the first thing you will create one frame, update underscore stack. Okay. First thing you need to create one frame. Every time you are calling a method, one frame will be created internally. So update underscore frame is created. Okay, then your control will jump from line number 13, and you are passing even. So from line number 13, your control will jump and it will go to update method. In the update method, your first parameter variable is E. Your first parameter variable is E. So what this E will hold? This E will hold 1000x. Why? Because E1 is holding to 1000x. Hello copy. E1 is pointing to 1000x. E1 is pointing to 1000x. E1 is pointing to 1000x. This E1 is pointing to 1000x. Same E1 of type employee. Same E1 of type employee you are passing to this E variable. So this E variable will also point to 1000x. Cello copy. Cello copy. Then you can see in the diagram. You can see in the diagram, all of you, what this E1 is pointing to 1000x and this E is also pointing to 1000x. Cello copy. Cello copy concept. Okay. Then you can see E.id is equal to 500. E dot, right now you are in update method. Don't forget that. Right now you are in update method. E.id is equal to 500. What is E? E is pointing to 1000x. E is pointing to 1000x. What is the value of ID? 200. This 200 will change. This 200 will change to 500. Keep patience. So many things it will give you. Okay. Then you are saying what? Line number 32. You are saying create a new object. So first you create a new object. Here 2000x, create a new employee object. 2000x, create a new employee object. Whenever you create a new employee object, always the ID value would be 100. Universal truth. Then this newly created object you want to assign on this E. E is a new variable or old variable? E is a new or old? Just write N or O. New or old variable. Right. This line you have declared or it was earlier declared? Very good. Excellent. Ravi and Prasanna and all of it is a new variable or old variable? It is the old variable. It is the old variable. So look, this newly created object 2000x, you are assigning to E. So E which was pointing to 1000x, now the same E will point to 2000x. Same E will point to 2000x. Okay. Then you are saying E.id is equal to 400. E.id is equal to 400. E means what? Now 2000x. Now 2000x. ID value is 100. That 100 will modify to 400. That 100 will modify to 400. Great. Then you are saying what? You are saying system.out.println E.id. System.out.println E.id. E.id. You want to print the value of ID. E.id. Look, E is pointing to 2000x. What is the value of ID? 400. Then tell me what is my first output? My first output would be 400. My first output would be 400. Excellent. Excellent. Absolutely correct. Absolutely correct. And now you can see this method execution is over. This method execution is over. Once this method execution is over, what will happen? It will be deleted from the stack frame. Once the method execution is over, it will be deleted from the stack frame. LIFO, last in, first out. It is deleted. Your control has returned back. It is deleted. Your control has returned back from update method to what? From update method to here. Control return back. Now you are saying system.out.println even.id. Don't forget you are in main method now. System.out.println even.id. You are in main method. E1 is pointing to 1000x. What is the value of ID? 500. E1 is pointing to 1000x. Don't forget you are in main method right now. So E1 is pointing to 1000x. What is the value of ID? 500. What is my second output? My second output is 500. My second output is 500, guys. My second output is 500. Okay. Then you are creating a new object. You are creating a new object. And please look at when you are creating a new object in the main method, E2 is a new variable, line number 17. E2 is a new variable. So here I will take 3000x. In this 3000x, I will create employee object. Whenever employee object will be created, always the ID value would be 100. Great. And this you are assigning to a new object. So one new object will be created here, E2. And this E2 will point to what? 3000x. 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 It is a new variable. Okay. Then after this line number 17, you are saying E2.ID 900. E2.ID 900. E2 is pointing to 3000x. ID value is 100. That 100 will change to 900. Okay. Then you are saying switch employees. Relax. Switch employees means what? Again, you are calling one method. You are calling one method. So whenever you are calling a method, what will happen? One new stack frame will be created. Switch employees underscore stack. Switch employees underscore stack. Okay, now switch employees underscore stack. Then switch employees underscore stack. What you are passing? You are passing E2 comma E1. All of you, please concentrate. E2 comma E1 you are passing. Guys, you are not passing E1 comma E2. You are passing E2 comma E1. That's why method name is switch employees. E2 comma E1. You are in main method. E2 comma E1 means you are passing 3000 and 1000. E2 comma E1 means you are passing 3000 and 1000. So what you are passing? 3000 and 1000. 3000x and 1000x you are passing. Please remember 3000x and 1000x you are passing from here. Then whenever you are calling this method, what will happen? One new switch employees as you created one stack frame, and you can see here two parameter variables are there, E1 and E2. Can you please tell me E1 will receive what? 3000 or 1000? Just write 3 or 1. E1 will receive what? 3000 or 1000? No, guys, E1 will not receive 1000. E1 will receive. No. You are leaving from the track. Look, E2, E1. E2 is 3000x. E1 is 1000x. So when you are assigning this E2 will assign to E1. That's why method name is switch employees. Now, you are going to switch the employees. So E2 will assign to E1. That means 3000x will assign to E1. And 1000x will assign to E2. First, you reconfirm. You understood? Otherwise, I will explain. That's why the method name is switch employees. You are not passing E1 comma E2. You are passing E2 comma E1. Everyone understood? That's why the method name is switch employees, to make it more interesting. Okay, now you are passing E2 comma E1 and you are receiving E1 comma E2. That's why the method name is switch employees. Okay, so tell me what is E1? E1 will point to 3000x. So go to here and here you write E1. First variable is E1. E1 is pointing to 3000x. E1 is pointing to 3000x. And look, E1 is pointing to 3000x. And what about E2? E2 is pointing to 1000x. E2 is pointing to 1000x. Great. Now you move. Look. Now here you are saying int temp is equal to E1.id. You have a temporary variable. You have a local variable temp whose value you are taking E1.id. Temp E1.id. Let's write this code here. Here I am writing to save our time. Right now we are learning this. Int temp is equal to e1.id. Int temp is equal to e1.id, guys. Int temp is equal to e1.id means here one temp variable will be created. This is a local variable and it is containing the value e1.id. E1 is pointing to 3000x. What is the value of id? 900. E1 is pointing to 3000x. What is the value of id? 900. Okay, this line is over. This line is over. Then you are saying e2.id. E2.id. E2 dot means E2 is pointing to 1000x. What is the value of id? 500. E2.id 500 you want to assign on E1.id. 500 you want to assign. Look, 500 you want to assign. 500 you want to assign on what? E1.id. E1 is pointing to 3000x. So this 900 will change to 500. This 900 will change to 500. Okay. Then you are saying E2 is equal to new employee. One new employee object you want to create. Create one new employee object. 4000x. One new employee object will be created. Whenever this object will be created, always the ID value would be 100. And this newly created object you want to assign on E2. This newly created object you want to assign on E2, E2, E2. So E2 was pointing to 1000x. E2 was pointing to 1000x. Now E2 will point to 4000x. E2 was pointing to 1000x. Now E2 will point to 4000x. Newly created object you have assigned. Okay. This line is also over. Now you are saying E2.id is equal to temp. That is temp value you want to assign on E2.id. E2 means 4000x. 4000x, what is the value of ID? 400. Yeah, sorry. 4000x, what is the value of ID? 100. In this 100, you want to assign temp value. Temp value is what? 900. Temp value is 900. Temp value is 900. That 900 you want to assign on E2.id. E2 is pointing to 4000x. ID value is 100. That 100 will change to 900. This is real object-oriented programming with so many manipulation, and you can give the output anywhere, anytime, any interview. Then this method execution is over, sir. This method execution is over means what? Now this will be deleted from stack frame. This will be deleted from the stack frame. This will be deleted from the stack frame. Great. Once it is deleted from the stack frame, you are going back in the main method. You are going back in the main method here, line number 23. Then tell me how many objects are eligible for garbage collector. You can see all these things are not there. All these things are not there. So from here you can reach to 1000x and you can reach to 3000x. That means these two objects are not eligible for garbage collector. 1000x and 3000x still not eligible for garbage collector. Why? Still these are reachable. Still these are reachable. So still these are reachable. So they are not eligible for garbage collector. So how many objects are eligible for garbage collector? Two objects are eligible for garbage collector. What are those? 2000x and 4000x. Two objects. 2000x and 4000x. 2000x and 4000x both are eligible for what? Garbage collector. And then finally look, e1.id, e2.id you want to print. Let me copy this. e1.id and e2.id you want to print. Here I am copying. e1.id and e2.id you want to print. Tell me e1.id, e1.id and e2.id. E1 means what? You are in main method. 1000x id. What is the value? 500. And then next e2.id. E2 means what? 3000x. What is the value? 500. Okay now? So 400 triple 500. Compile this program, save, compile, run. 400, 500, 500, 500. 400, 500, 500. Tell me, everyone understood heap and stack diagram? Two more programs are there. Of course, it is not possible to complete today. We will complete tomorrow. But tell me, everyone understood? You understood this terminology? You got heap and stack diagram and you got the confidence today that you can give the output of any complex to complex program. Now you have any complex to complex program, you can give the output. That is the beauty. Okay, guys. Now it's time to what? It's time to share notes. So I'm just sharing you the link of one WhatsApp group. You try to join, then I will share the notes in there only. Okay, I will share the notes in there only, and I will share the link also. Wait, I will share the link also. So first you try to join. Look, I'm going to share. I'm going to share in the what chat window. Please try to join. Please try to join. In this WhatsApp group, I will share the notes. In this WhatsApp group, I will share the notes. Are you able to join? Please write in the chat window. Then I'm sharing the link also. My first day video link I'm sharing. Please give me some time. Meanwhile, are you able to join? I will share the notes. Can't see the link. Oh, wait. Now, now are you able to join? Now, please join. All of you, please join here. I will share the notes in the text file. Okay. Do you have any question or anything? Anybody is having any question? I will share the notes. Okay, I will share the notes. And second thing is what you can go to the YouTube channel actually, and you can search Naresh IT webinar. You will get what JVM architecture video. Let me check if it is available. Then I will share the right now. Meanwhile, if you have any question, you can ask. I will share the notes in the text file. Anything you want to ask, please ask. And do one thing, I will share the webinar link in this group also. Okay, now both today and yesterday I will share. So that's all for today, guys. Okay, tomorrow again we will meet at 6 p.m. to understand more heap and stack diagram program. It's very nice. The session was very nice. You guys was excellent. You have given the right answer. I'm very happy. Tomorrow 6 p.m. we will again meet. Thank you all of you. Just go and revise all these concepts. Chandra, actually now what? Now from meta space concept, you have only heap and stack. Okay, now everything is available in heap. Just search in the Google what is meta space, you will get more idea. Meta space. Thank you, Prasanna. Really happy. Good. Definitely, if you do practice in pen and paper, it will give you the confidence. Okay, guys, I'm sharing the notes. Thank you, all of you. Metaspace. Yes, metaspace. Absolutely correct, Chandra. Earlier, it was permgen, Permgen. Literal means the constant. Value is the English word. Literal is a Java word. Literal means constant. Rohit. Okay, now? Great. Thank you, guys. No, 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 Rohit. Memory management purpose, we are not using literal. Literal, we are using to assign the value to a variable. Any constant value you can assign to a variable by using literal. We have five types of literal: integral literal, floating point literal, character, Boolean, string literal. Okay, guys. Thank you, all of you. I'm sharing the notes. Now you try to send me a mail or I will talk accordingly. Thank you, Sai.